Hi everybody, welcome to this self-check section 9.5 video. So let's go ahead and take a look at number 3. So number 3 states in the manual how to have a number one the easy way, it is stated that a song must be no longer than 3 minutes and 30 seconds, which equates to 210 seconds. A simple random sample of 40 current hit songs results in a mean length of 252.5 seconds. Assume that the standard deviation of song lengths is 54.5 seconds. Use a 0.05 significance level to test the claim that the sample is from a population of songs with a mean greater than 210 seconds. So let's write down some of the things we know. Okay, so let's go ahead and pick apart this question. Okay, so a simple random sample of 40 current hit songs. Sample of 40, so that's n equals 40. Okay, so this sample of 40 results in a mean length of 252.5 seconds. So that's going to be my sample mean, my X bar. So X bar equals 252.5. Okay, let's go ahead and keep reading. So assume that the standard deviation of song lengths is 54.5 seconds. So this is actually our sigma, our population standard deviation, because this is talking about all song lengths, not just the 40 song, all song lengths. That standard deviation 54.5. So let me write that down. Sigma is 54.5. So use a 0.05 significance level. So that means alpha equals 0.05. And then lastly, test the claim that the sample is from a population of songs with mean greater than 210 seconds. So that means mean is greater than 210. So that 210 is going to be my mu naught. Okay, so let's go ahead and build our hypotheses. So null and alternative. So it says test the claim being greater than 210. So that means the alternative is going to be my claim. So mu is greater than 210, and that's my claim. And my null is going to be the exact opposite, so less than or equal to 210. So calculator work, since we do know the population standard deviation, sigma, we have to use z-test. So z-test, and since we aren't given a list of data, we're going to use the stats option. So stats 210, 54.5, 252.5, 40, and greater than. So let's go ahead and throw this in the calculator and get our test statistic and p-value. So stat test z-test. So we're picking the stats option. So mu naught was 210. Population standard deviation was 54.5. Sample mean was 252.5. The sample was 40. And our alternative hypothesis, what's that saying? It's saying greater than 210. So once again, I am choosing greater than. Okay, so hopefully you have all this information in here. And let's go ahead and hit calculate. Okay, so I get a test statistic of 4.93. and a p-value of 4.07. But remember, there's that e to the negative 7 at the end there. So this is making this a very small number, basically 0. So let's go ahead and write that down. So z equals 4.93, and the p-value was 4.07, but then it had e to the negative 7. So once again, this is basically 0. Okay, so now let's come up with a conclusion about the null. So this is where we compare p and alpha. So our p-value was 0, and our alpha is 0.05. So that means our alpha, without much argument, is greater than our p-value. And that means we reject the null. Okay, so we have no equality in the claim, and we reject the null. So follow the conclusion table, and I'm going to pause the video and try to come up with a conclusion and then compare results to what I have written down. Okay, welcome back. So hopefully you came up with a similar conclusion statement as I did. So following the table, no equality claim, reject the null. You should have came up with there is sufficient evidence to support the claim that the sample is from a population of songs with mean greater than 210 seconds. Okay, so that's it for number 3. This is an example of a population mean where we had to use z-test because we're given the population standard deviation sigma. So that's it for this video. Thank you for watching. I'll see you in the next one. Goodbye.